Hi there, and a very warm welcome to this week's Quick Tip. In this week's Quick Tip, we are going to take a look at the legends of the keycaps. Now, while this might be a movie title, what I'm talking about is the keycaps that I posted recently and the lettering on them. So I have a special technique in putting these letters on those keycaps, which is very efficient but also a bit nerdy. So grab your coffee and let's dive in. Alright, before we jump into our scene and build this, let's actually have a look at our finished product. So we have the scene here where one keycap is distributed with a cloner as a render instance, and this makes this scene very efficient even if you have a lot of keycaps, because the original keycap with the original geometry has to be only loaded once. Now, as you can see, all of those keycaps have different legends on them, and the great thing about that is if I go and increase the count here, you can see those legends are dynamically distributed to the keycaps, so every one of those gets their own. What's happening in the background is that we are loading a texture with all the legends upon it, and we are dynamically deciding which portion of the texture here is mapped to what keycap. And this is a shader tree that we are going to build next. So let's jump in. Okay, let's start by talking about the texture, because this is one of the most important ingredients in our setup. So I decided to not use all the legends of a real keyboard, but limit the scope to actually 10 legends, as this is more understandable later on. So what do we have here? If I go to line mode, you can see I have little squares here, and in the middle of every square there is my legend. What I'm doing here is make the scope of the texture its ratio. So basically we have 10 legends here, so the ratio of the texture is 10:1. That means if you go for full keyboard legends, you have an aspect ratio of 104:1, because a full-sized keyboard usually has 104 different legends. Oh, and yes, I'm using Illustrator here, but you can do this in any application that you like to make textures with. What's really important is that you keep the aspect ratio, or at least that the spacing is the same no matter what you do, because that even spacing is what makes the shader work and map the legends to the right place on the keycap later on. Okay, really small interlude here to show you what I do to get textures for my Illustrator files. Basically, I have Photoshop open and I drop my Illustrator file in here. Now, I already done that before, obviously, so I know a height of 200 pixels is great. And we can see the width is now 2000 pixels. This is this 10:1 aspect ratio, so we are golden here. Basically, what we can do next is get to a grayscale value to save on some space of our hard drive, and then click OK. Now, the guides are still visible in here, but this doesn't matter at all. So I'm going to create a background layer. You can't see this because the layers are on my other screen, but we are going to choose a white color and the fill tool and fill this. And then we are going to go to layer and flatten image to have just one layer. And then last but not least, we hit Ctrl I to invert that. And this is the texture we'll be working with to finish our scene. Alright, welcome to our scene. So if you follow this channel for a longer time, you know that this is our trusted keycap scene, and we have it in some other tutorials as well. What's pretty much new is that I upload all my scenes that I use in tutorials now to my Patreon page, and you can gain access if you become a Patreon. So head over there if you're interested, the link is down in the description below. So since this is more of a rigging and not a shading tutorial, basically a shader rig that is, we are going to get with very basic materials. So what I'm going to do is go Material, Create, and then go with a glossy material here, and then call it Keycaps. Here we go. Now we are opening the node editor here and make some of the basic adjustments to the material. So what I want to do from the start is go to the basic, and then set this to GGX energy preserving. Then go to the index and set this to 1.5. And then go to the diffuse color and set this to 0.1. And last but not least, to the roughness and set this to 0.25. And then assign that material to our keycap. Alright, let's bring in the texture by dragging and dropping it into the node graph here. And actually, since we are not having colors, as we said, let's set this to float here too, to save on some precious VRAM, and then connect it to the diffuse. This is looking rather strange right now, and the reason is that the texture tag here is box projected, or cubic as it's called in Cinema 4D. Let's right click and fit to object here, and now we can see the texture with all legends is projected on every side of the keycap. This is obviously not what we want. We want to have one legend at the top. So let's take it a step at a time. And the first step is to change our projection from cubic to flat. Now the flat projection is on the side, not on the top. So we need to change the coordinates here. And actually it's the angle P that we need to fit by -90. So we are now projecting on the top. So to actually show only one legend, we have to remember our aspect ratio. And the aspect ratio is actually done with the scale here. So we have a scale that mimics an aspect ratio of 1.1 than anything else. So what I did before is go in here and set this to 8. And then this should be 10 times the size of 8, which is 80. Now we can't see anything because we just landed in between two legends. But if we drag our texture over, for example, to the first legend, you can see this is working pretty well. So let's clean up our coordinates real quick by going here, typing in a value of 72, a value of 0, and the set scale should be also 8. Here we go. Now we can move on. So what we are searching for here is a way to skew our texture over by a certain amount so we can see different legends. So let's demonstrate that by going with an UV transform here. And let's go to the X translation and let's move it over. So we can see we can scroll through all the legends here. And this is working great. But we want to have a way to automate this. And to best automate this, there should be an input here. But we cannot have an input in our transform. So let's actually go with a projection. Here we go, projection. And there's no input here either. But you can see there are different modes that we can use here. And one of them is Distort Mesh UV. And if I click here and get Show All, you can see we have some inputs for rotation, scale, and actually what we need, the translation. Let me explain what this is doing a little bit more in depth. So to make it more understandable, let's take an RGB spectrum here and set it to 0 and then plug it into the translation. And as we do that, you can see that now the slider here is gone and replaced with the texture. So we have an input value here. And then we have basically a range mapper down here. So right now it's remapping black values to 0 and white values to 0. So not a lot is happening right now. But if I go and remap white values to 1 and then choose to slide the red slider here across, you can see we are now translating the texture across our object. Now, there's a small bug in here, at least I think so. So if we go to the red value and slide it to 1, we end up with the L. And we should end up with the value we started, and this is the escape. Now, we need to find a translation value that puts us back to the escape, and this is actually 2. So I would expect a range of 1 to shuffle through one UV set, so we end up with the start position, but for some reason 1 gives me only a half UV set. Let me explain the thought behind that real quick. So usually you have a UV set, and by moving it one set over, you end up with the same position than you started. And basically I would expect that to happen with a value of 1. So this is one UV set. But for some reason here it's a value of 2. But at least we can get it going, and now that we know, we don't bother anymore about that. Last thing I need to mention here is we moved only the red channel, and this is because this is the U and V coordinates. So if I put that back to 0 and go for the green channel, you can see that is feeding the translation of the V coordinates, which you don't need, because all our letters or all our legends are along the U coordinate range of the UVs. What we need right now is the right values so the legends click into place. So since we are on a 10 legend basic, this is rather simple to see what we mean. So if I go to the R channel and put it 0.1, you can see we are now getting the symbol here. 0.2 gives us the arrow. 0.3 gives us the smiley, 0.4 gives us the V, and so on. Now, if you have keen eyes, you noticed we are stepping through them backwards. To actually step through them forward, we need to put that to -2 here. So this is now the right direction, 0 being escape, and then 0.1 should be hello world, and 0.2 should be the home key. And this is correct. Just to prove my point, here is our texture, and we're going from escape to hello world to home to enter and then so on. If you are a hardcore fan of the channel, you might remember a video named Fun with Math Notes. And actually we are going to use the same principle that we used there. And this is going to the object, to the extensions, and create an Octane object tag here. And you can see the instance ID here. Now the instance ID has a node on its own. So if I go over here and I search for it before, you can find the instance range. In the instance range you can find the maximum ID. So what this is basically a stepping value. So let's put that up to 10 and actually connect it to the diffuse here. So let's render this and let's see what's coming out here. And our result is black. But watch what happens if I go to the instance ID and get the values higher. So you can see we are going up to a white value when we hit 10, and then we are going back to black when we hit 11. And this ends in an endless cycle that always repeats. Nice, so we have our stepping here. Let me get back to 0 and then go and figure out a way how we just deliver the red channel to our translation here. Since we don't want to use also the V channel for our UV coordinates, we just are interested in translating the U coordinates. So to do that, we actually have to scroll down here or find the channel merger in our tab menu. So here we go, we just can plug that into the red channel and then plug that into the translation. Now, for some reason, the unpopulated channels here have a standard value of 0.5, but we need a value of black or 0. So let's get in with a float texture that we set to float 0 here, and then plug that into green and blue. And now if we go and select the texture and put it into our diffuse and then step through the instance here, you can see now we have made a legend translation for our keycap. Here we go. Okay, before our great reel, let's actually care about shading a little bit. So let's scroll down here and get the Octane gradient here, and let's remap some values. So we want to remap black values to around a lightness value of 30% and the white values to a lightness value of 75%. So we get a more natural tonal range here. Alright, now that we've done that, let's actually move that keycap to the side a little, as we have another one here. So let's make this visible and actually transfer the Octane object tag and the texture tag to that object. And now be ready to have your minds blown, as we can now control the texture on a per object basis. So we have a different tag with a different instance ID, and now per object, different parts of the same texture are actually mapped to that object. Isn't that cool? While this is very technically impressive, you could argue to go to the texture tag and actually move the texture the old-fashioned way, since you can do that for every object. While I agree with you, I also have to mention that changing numbers is vastly more efficient than finding the middle spot of every legend on your texture. But I actually have more arguments for it. For example, if I turn on those both instances here and copy one of those render tags on there, the object tags from Octane, and then change the value. For example, let's actually use the smiley here, and let's use the V here. So you can see there's nothing changing. But the reason is not that it's not working, but that there is no update. So if I update by re-rendering, you can see we get the V as we said and the smiley here. So this is huge, because now instead of a texture tag, you have a render instance that is very efficient for the scene, and you can still choose the texture that is displayed on top of it. And as you've seen in the beginning, the really cool thing is that you can use cloners, and if we set that to a reasonable level here and actually go get this to produce render instances, that a cloner produces their own instance IDs. So let's try to show you by getting everything turned off but this one keycap and move it into the cloner. And you can see now the cloner gives its own instance IDs and therefore creates the own legends here. And because of the way how this is set up, if we go for more keycaps here, you can see those each get their individual legend assigned. Now we have double legends because those are more than 10 keys here, but you get the idea. As I can think of now, there's only one very small drawback here, and this is the initial projection. So if we use any other textures in the same context, those projections will also apply to them. So if we drag in a UV map here and apply that to our diffuse for a second, you can see that this is awfully distorted. So the top is distorted 10:1 and the sides are distorted because it's projected from the top. So actually a workaround for this is to give each other texture its own projection here, and then in the projection, for example, select box and then go from there. So if we make this smaller here and have the aspect ratio for all the same, you can see that you would make the case that this is now fitting a proper cubic projection while you use the UVs of the object for the lettering. Last but not least, there is very little in our way to change the scope of the legends to a broader range. So let's actually go and load the key lettering 01 that is supplied with the Patreon scene. Now you can see we have multiple legends on the keycap again, and this has something to do with the aspect ratio. Now as you can see, the dimensions of the texture has changed. It's not 10 legends anymore, it's actually 86. So we have to take 8 times 86 to get the right proportion. Now while we land on a keycap already, we need to also get the position here to the first one. So something like this. So we see our escape. And now the only thing that is left to do is go to our instance range here and set the number to 86 also. And now if we step up the instance here, you can see we now can step through our lettering or through our legends here without any problem. So we have finally upgraded to a bigger legend set and it works flawlessly. And this concludes our tutorial, so I hope you learned something and you find some applications for this in the real world. If you do something fun with it, let me know. And if you're still watching, thank you for staying with me for so long. Also, a huge thanks for my Patreons. So, big news today, we have our first €50 tier subscriber, and his name is Gilles Augustinen. Hopefully I didn't butcher this name. Other thanks go out to George Luna, Laon, Leon Studio TV, Marty Kane, Part 1 of 2, Raiko, Render King aka Alessandro Bonchio, Scene CGI, Shamus Johnson, and Yassin Rupp. If you like the content here and want to support me, please consider becoming a Patreon. The link is down in the description below. Other than that, if you have ideas for future tutorials and trainings, please let me know in the comments. If you're interested in seminars and one-to-one sessions, please feel free to contact me. And this is it. Thank you very much for watching again, and happy UV offsetting your legends. Bye!